Okay, everybody, we're going to do solving radical equations. This is Unit 3. And we just finished up graphing radical equations, and in that section we were graphing and we were doing transformations on the graphs. And let's say that we had a graph that maybe had to be transformed to the left and down, and the vertex is down here. So that graph, being face up, would go something like this, and that would be your radical function. So if the solutions to this radical function, there's just one solution, and it's going to be right here. Your solution is where your radical function crosses or touches the x-axis. So if we wanted to find that exact spot, we could do it algebraically, and that's what this section is all about. It's about solving equations algebraically by hand and finding those solutions, and those solutions are actually where the graph would touch or cross the x-axis. So when you're doing these solutions, in the back of your mind, I want you to be thinking, okay, if I were to graph this, it would be where it would touch or cross the x-axis. So we've got some steps to follow. There's 4 steps total. The first step when you're solving a radical equation is to get the radical by itself. The second equation is to, or not equation, the second step in solving radical equations is to raise both sides to the power of the index. So what do I mean by that? Well, if you have square roots, say you have a square root, the index right there is really a little 2, even though we don't see it. And so we would raise both sides to the second power in order for that square root to go away, because ultimately we're going to want to cancel those out so that we can solve for x. If you had a cube root, there'd be a little 3 as the index, and then in order to get rid of the cube root, we would have to raise both sides of the equation to the third power so that these would cancel out. So that's what I mean by step 2. And also, if any time during a video I'm going too fast, please feel free to pause the video and write down things so you can catch up. Okay, step 3 is to solve for x. You're just going to use your basic Algebra 1 skills to do that. And then step 4 is going to be to check your solution. So when we check our solution, sometimes, a very small part of the time, but sometimes we have a solution that just doesn't work. And even though we did all the algebra correctly, it still doesn't work. So that is called an extraneous solution. And that's when you plug it back in, which we're going to be doing for step 4, and it just doesn't work. Okay, so get used to that vocabulary. When you see that, that means that it's a solution that just doesn't work. Okay, so let's start some examples so that we can get going in this. First example of our solving radical equations looks like this. Let's say we have 2 equals the square root of 12 minus x. So your first step is to get the radical by itself, and this one is all by itself already. This square root is the only thing on the right hand side of the equation. It is all by itself. So step 1 is done. Step 2, you want to raise both sides to the power of the index. Okay, so this is a square root, which means there's really a little 2 right there. So to get rid of the square root, we're going to square both sides. We've got to do this before we can do any of our algebra. I'm not able to add x or subtract 12 until this square root is gone. Otherwise, they're kind of trapped underneath there, and we can't do any operations until that square root is gone. So the nice thing about this is that it totally cancels out. All you have to do is bring down the 12 minus x, and then the 2 squared is 4. Okay, now use any type of algebra that you've learned to solve for x. There's definitely more than one way to do this. I'm going to add x to both sides. I like to do that so my x is positive. And then this is really a plus 4, so this will be x plus 4. This goes away, equals 12. And then I'm going to subtract 4 from both sides. So x equals 8. Okay, so we solved for x. Step 3 is done. Now the last thing that we need to do is check. And I'm going to use my graphing calculator to help me check for this, clear it out. So what I want to do is I want to put this 8 wherever I see an x in the original equation. Okay, so I don't need to put this part over here in, I just need to put in the right hand side. So this originally was the square root of 12 and then minus x. So I'm going to put an 8 in that spot, and then I'm going to arrow over and hit enter. Okay, so we get 2. That's a good sign because originally this equation was set equal to 2. So therefore this solution works and we're good to go. Let's try another example. So for this example, let's do something that looks like this. The square root of 2a minus 18 equals the square root of, we'll do 12 minus a. So now this one looks a little bit different. We have 2 square roots. So that step 1, getting the radical by itself, just means that this square root needs to be over here, and the other square root, since there is another one, needs to be over on the other side of the equal sign. So these are by themselves. They're away from each other. One's on the right and one's on the left. So now we can go to step 2. You want to raise both sides to the power of the index. So this is a square root, so there's really just little 2's right here. So we're going to raise both sides to the second power. We're going to raise this side to the second power. And this cancels out. Bring down the 2a minus 18. Cancel this out. So this is 12 minus a. So now step 2 is done. We're now going to do step 3. So you can use whatever type of algebra you would like to get a by itself. So I'm going to add a to both sides. This will be 3a minus 18 equals 12. And then I'm going to add 18 to both sides. So 3a equals 30. Now we need to divide by 3. So a equals 10. Okay, so we got an answer of 10. That's step 3. Now all we have to do is check it. So wherever we see an a, we're going to put 10. So I'm going to do the left-hand side, and then I'll do the right-hand side. I'm doing the left-hand side for this one because I have an a over here. So I'll have to do it for this one and see if they match. Okay, so we had a square root originally, and then this is 2 times our answer, which is 10, minus 18. And then we hit enter. We get some crazy looking decimal that looks like the square root of 2. Now we're going to go on, and over here we're going to plug that in. So the square root of 12 minus, and then we put our answer in, which is 10. And we get that same decimal. So therefore 10 is a good answer. It works. They equal each other on both sides. Okay, let's try another example. I'm going to go onto the back of my paper for this one. Same idea. This is all the same pattern. Still following the same steps. So 9 minus 12b under the square root. Okay, so step 1, if you remember, is to get the radical by itself. Well, this radical is not by itself. There's a -1 hanging out right here. So we got to get this -1 over to the other side of the equal sign before we can go on to step 2. So to move this over to this side, you're going to add 1 to both sides. So 8 plus 1 is 9. That equals the square root of 9 minus 12b. Okay, now the square root is by itself. We're on to step 2. Raise both sides to the power of the index. So we're going to raise this side to the second power. We're going to raise this side to the second power. So 9 squared is 81. This goes away. 9 minus 12b. Okay, now step 3, solve for b in this case. So this is a positive 9 right here, so I'm going to subtract 9 from both sides. 81 minus 9 is 72. That's gone. This is a -12b, so I'm going to bring down the -12b and then divide by -12 on both sides. So that goes 72 divided by -12 is -6. -6 equals b. So that's the solution we came up with. Now we need to check it. So I'm going to plug in to the right hand side of the equation. Okay, so this is -1 plus the square root of 9 minus 12 times our answer. Our answer was -6. I plug that in and hit enter, and I get 8. That's a good thing. Therefore, this answer works. So sometimes we may have roots that are other than square roots, like we may have a cube root or we may have a 4th root. So let's do one of those. Let's try this one. So let's say we have the cube root of x plus 2, and let's see, minus 5 equals 1. Okay, so I want to show you that this is the same process as before. Just instead of a square root, you're going to have a cube root. So now you're going to get this by itself. Right now there's a minus 5 right here, so you're going to add 5 to both sides. This goes. This is 6. So the cube root of x plus 2 equals 6. Now, the second step is to raise both sides to the power of the index. That's really a 3 right there. So we're going to cube both sides. So x plus 2 equals 6 cubed is 216. Now we're going to subtract 2 from both sides. To get x by itself, x equals 214. That's our answer for that one. Let's check it to make sure that it works. Remember, if at any point I'm going too fast, please feel free to pause this and then you can catch up. Okay, so a cube root is in a different spot than the square root. If you go to the math button on your calculator, which is right here, and then you go down to choice number 4, you can get a nice cube root there. So I'm going to plug 214 in wherever I see an x. 214 plus 2, and then the minus 5 is not underneath the cube root, so I have to arrow over to get out of that cube root. And then minus 5, and I hit enter, and our answer is 1. So therefore, we have a good solution. Okay, so now try the practice problems in your homework. See if you have any questions, and I'm happy to help you. Thanks.